Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of writing problems for equations and inequalities. This is standard 8.8b in the great state of Texas, and we are using item number 26 off the 2018 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a simple equation, 7x plus 1 equals 10x. We have a variable on both sides. We need to match it to a problem situation. So let's read these answer selections here and see if we can write something that would work for them. So Brody ran at a constant rate of 7 miles per hour. Okay, so Brody, 7 miles per hour. Candace ran at a constant rate of 10 miles per hour. So I'm seeing that 7x and the 10x. And started 1 mile in front of the starting point. What is x, the number of hours that Brody and Candace would have to run in order for their distance to be the same? Well, so we need Brody and Candace to be the same. All right, so we're going to say, Brody equals Candace, and then we're going to kind of replace. So Brody is 7 miles an hour, so if x is hours, so that's 7x for Brody. Candace is 10 miles an hour and started 1 mile in front of the starting point. So that's going to be 10x, 10 miles an hour, plus 1 mile in front. So we're really close, but obviously the plus 1 is on the wrong side. It's with Candace, not with Brody. So not F. Let's check G. Brody played a game where he scored 8 points per hour. Candace played the game, so 8 points per hour. Candace played the game, scored 10 points per hour. What is x, the number of hours that Brody and Candace would have to each play for the scores to be the same? So once again, we're doing Brody and Candace the same. But, Brody's just 8 an hour, and x is number of hours. So it's just 8x equals 10x, which can't work. That's not going to work. And so what they did, I think, they just put the 7x plus 1, and they turned that into 8. Yeah, that doesn't make any sense. All right, so we're thinking no for G, no for F. Brody went to 2 different amusement parks. The first park, all right, looks like there's no Candace here. $7 an hour. Wow, $7 per hour to go to an amusement park? That's kind of weird to be charged per hour. Gave a 1% discount for showing a student ID. The other park charged $10 an hour. What is x, the number of hours that Brody would have to stay at each park to have to pay the same amount? Okay, so this is, instead of Brody and Candace, this is park 1 needs to equal park 2. Park 1 equals park 2. So let's see, $7 per hour. X is the number of hours, so once again we're going to do 7x. And gave a 1% discount. Yeah, so if you're doing a discount, that's -1, and that's really not even just like 1 in itself. It's 1%. If we wanted to make that a decimal, it'd be like 0.01. And then the other park is $10 per hour, so that's going to be 10x. So it's closer, still not there. So let's hope it's J. Brody rode his bicycle on 2 different days. The first day he rode 7 miles per hour, started 1 mile from his house. Second day, 10 miles per hour. That's looking a little bit better. X is the number of hours, and we're doing both days. So we need day 1 to equal day 2. Day 1, 7 miles per hour. X is our number of hours, so we're going to do 7x. 1 mile from his house. See, this is the difference. This 1 mile from his house. 1 mile. See, this one was in front of Candace. Now this is with our day 1. Then the second day he started with this and he rode 10 miles an hour. There we go. That's looking a little bit better. You've got the 7x and the 10x obviously on 2 different sides of the equation, but the biggest problem seemed to be this plus 1. It needed to be with that 7x. And so that is our answer, J.